Okay, so we've been learning in the previous lessons about dilations. Okay, so far we've learned that a dilation is created when we multiply by a scale factor, okay, where AB moves to A prime B prime because the center is not on the actual segments. Okay, so what we've learned so far is that we can take the original AB, multiply it by the scale factor of K to create the dilated image noted by the primes. Okay, so K again is the scale factor. All right, and now what we should recognize as well is that the idea that the image is parallel. Okay, so when we're talking about that, we're talking about AB is parallel to A prime B prime, so it's creating parallel images. Okay, what we haven't talked about in the lessons prior is that these little triangles right here, these little triangles that you can see on the line, they're actually trying to tell you that means parallel. Okay, moving on to the first exercise. All right, so in this first exercise, they said in the following diagram, B, A, C has been dilated with a center of D and a scale factor of 2. So here's D. And by a scale factor of 2 to actually create B prime, A prime, C prime. Okay. Now what they're asking you for in part A is just to name the parallel rays. So if we remember from the previous lessons, they should be the same. Okay, meaning AC. Now if we denote that, remember we need ray, so it needs an arrow on it, is going to be parallel to the one we can see in the image of A prime, C prime. And we have one more ray, the one on the bottom part, which is AB. So we also have the ray of AB is going to be parallel to A prime, B prime. Okay. But it did indeed get twice as big. So if I measure from A to B, we could see that's almost 5.5 centimeters long. And here, that's about 7.5. So let's go back. So it might, oh, sorry, to B, that's 3.5. And if we go from A just to B here, it's about 7. Okay, so we went from about 3.5 up to a length of 7, which would be that scale factor of 2. Okay. So now remember, I can either take AB and multiply it by 2 to get to 7, or I can go from 7 and divide it by 2 to get back to 3.5. All right, now I've already measured both of these angles, and when I measured, angle 1 came out to be 35 degrees. Now, some people would think, oh, well, if I'm multiplying by a scale factor of 2, 35 should increase to 70. Well, let's take a look. There's angle 1, and if I move that down to angle 3, you can see it matches it. So therefore, the measure of angle 3 is still 35. Okay, well, reason being is that a dilation only changes the length, it does not change the size. Or it does not change the shape. Okay? So if I had a rectangle and all angles were 90 degrees, if I dilated that same rectangle, it didn't change the shape. It's still a rectangle, which means it still has all 4 90-degree angles. So a dilation changes the size, but not the shape. What does that mean? That dilations are angle preserving. Okay. In other words, the angles don't change. So the one thing that we need to remember is that do not multiply the angles. Remember, that's the notation for angle. The angles by the scale factor. They're not affected. Same thing as slope. Slope's not affected by it either. Okay, and remember, the letter representation for scale factor is K. So now, if we're looking at the question below, and triangle DEF is dilated by a factor of 5. Okay, so what does that mean? It means the triangle is going to get 5 times bigger. So if I look at this triangle and I dilate it by 5, it gets bigger. But we just said that the angles are not going to be multiplied by the scale factor. So these symbols of angles mean they can't be the choices, because the scale factor is not going to change the angle regardless. Okay. So this one here is my original, and this one here would be my dilated image. Okay. So now we're down to choice 2 and 4. Right, if we look at these very carefully, the scale factor generally will get multiplied by the original to make it 5 times bigger. So if all these sides were 2 for DEF, we'll make it equilateral. Then all the new numbers would be 10. Okay, now let's plug in these numbers that we just made up to help us understand. If I go from E to F, it's 2. There's that scale factor. Here's E prime F prime. That's a change of 10. Okay. Is 2 going to equal 5 times 10? Nope, it's not. So it can't be that choice. But let's test that same theory over here. DE is 2. And 1/5 of, well, let's look at D prime to E prime. That's 10. Well, if you do 1/5 times 10, yep, I get 2. So therefore, I know my correct answer is 2. Okay, so again, dilations only affect the side lengths. It does not affect the slope. It does not affect the angle. So it's angle preserving. Okay, moving to the back. So looking at the back in exercise number 3, in the triangle and diagram below, E prime, F prime, G prime is the image of EFG, meaning that this is the dilated one. This is the original. By an unknown scale factor and an unknown center point. Okay, we don't know where it's being dilated from. Okay. So the one thing that we want to start to learn about as we're working further with dilations is what angles match with what angles and what sides match with what sides on the 2 different triangles or 2 different shapes later on. One way to know is by the lettering that they give you. It's generally in order: first, second, and third. This is how we need to know that E is going to match with E prime. Okay. So angle E equals angle E prime. Why? They're both in the first position. Angle F equals angle F prime. Why? They're both in the second position. And the last one is angle G with angle G prime. Same reasoning. Okay, now we're going to graphically determine the location of the center of dilation. Now, some of you guys have done this before, but have never really paid attention to it. probably back when you were in like 4th, 5th grade. You created an image that somewhat looked like this. And then what you've done is to create that box, you would connect these corners. And that creates our 3D box. Well, we're going to do that same type of thing to the image down here to find the center of dilation. Okay, so what I'm going to do is I'm going to connect F with F prime. I'm going to connect E with E prime, and you can use any straight edge to connect these. And I'm going to do the same thing with G and G prime. Okay. Right. So what you'll notice is that they all meet back at a center point. This right here, and mark it D, this would be the center of dilation. Now, in art class, it's known as the infinity point. I mean, you can keep trying to draw little triangles to connect all three of these if you keep them parallel to the original images. And we can keep continuing to try to make little triangles until it looks like eventually it disappears. Okay, so now we're going to work on how do we find the scale factor. So it says here, and calculate the scale factor. And to this one it says to the nearest tenth. So we might get decimals. We might have to round if it's telling us to round to the nearest tenth. All right. So what I'm going to do is I'm going to measure two sides, just two, right? If I measure E to F, oh, I'm getting about 2 centimeters. So I measured EF. EF was the original, and I got 2 centimeters. I'm going to measure its corresponding side, which means its matching side, which is E prime F prime. And it's a little shy, but we'll just round it up just a little bit. It's 3 centimeters. So we got E prime and F prime to equal 3 centimeters. Okay, so now all we have are two numbers. Okay, so now remember, at the beginning I said the originals get multiplied by the scale factor, which means this is the original. So I'm going to take 2 and multiply it by k. 2 times something should give me 3. Right, so now we got to figure out how we get k. Okay, so if this looks somewhat familiar, it's like doing a one-step equation. We're right here. Oh, I do apologize, you can't see that. Again, EF was 2. E prime F prime was 3, and I set up the original times k equals 3, the dilated image. So just divide by 2. Okay, and what you will get, 3 divided by 2, actually just gives you 1.5. Okay, so k is 1.5. I'm just going to fix this, make it look more like a 2 for you, in case there's any confusion. So k equals 1.5. So there, we figured out the scale factor is 1.5. That means the image is 1.5 times bigger than the original. Okay. Moving down to A, 4A. Okay, in the diagram below, triangle ABC. Okay, so what they're trying to tell you is that from A to B to C, that's the original. D and E, D and E, have been located on AB and AC such that DE is parallel to BC. So again, remember that symbol for parallel is those triangles. It doesn't mean they're congruent, it just means that they'll never touch, they'll never intersect. Okay. So for this one, it wants us to give a dilation that will map the big triangle on to the little triangle. Okay. So if you hadn't noticed, the dilation actually created a triangle that is smaller than the original. Okay. So now we need to specify both the center and scale factor of the dilation. if we look at this, we can kind of see that point A, that's our center. How do we know that? If I connect from B to D, it leads me back to A. And if I connect from C to E, it leads me back to A as well. So that means that A is the center of dilation. And how do I know that as well? It didn't move. Now I need to do the second part that they asked me for. Okay, they asked me for the center and scale factor. Okay, so again, I kind of got to measure some stuff. Okay, remember, the big triangle is my original, so I'm going to measure. Okay, that's about 7.5. Okay, so AC equals 7.5. And now I need to measure AE because that's its matching side. Okay, A to E is almost about 5. We'll call it 5 centimeters. So again, these don't have primes on them. So it's very important that you pay attention to which ones were the originals and which one's the dilated. A to C is the original according to the triangle up here. Okay, so that means 7.5 times K is going to shrink me down to AE, the dilation of 5. Okay, so the same way that I did it before, I just divide by 7.5. Divide by 7.5. Okay, so I'm going to take 5 and divide it by 7.5. Oh, I get 0.66666, and it keeps going. So I'm going to make that a little easier for myself. I'm going to use the math key that's down here. And I'm going to tell it to convert that back to a fraction. Okay, that looks a little better. 2/3. So my scale factor here would be K equals 2/3. All right, so now I'm going to skip part B, move on to part C. Part B is not really that important, so I'm going to skip right to part C. Okay, we're going to work on in the next couple lessons of how to set up proportions. With that being said, we need to be able to match corresponding sides of a big triangle and a little triangle. Okay, so I like to set it up. Oh, I'm going to always remember, I'm going to put big over small. Not the original over the dilated, but one has to be bigger than the other with a dilation. Okay, so if I labeled this information up in this picture, remember it has nothing to do with the scale factor here that we found. This is a completely different question here. Okay, so it said A to D is 10. That's small. A to B is 15. That's the big triangle. These would be corresponding sides because they match. Okay, B to C is 12, big triangle, and A to E from here to here is 14, and that's of the little triangle. Then algebraically determine the lengths of DE and AC. Okay. DE is of the little triangle, and AC is the big triangle. So when they give this many numbers to you, chances are you can set up a proportion. Okay, so I'm going to set it up. This side has both the numbers, so I'm going to use those numbers. Big over small. So I'm going to do 15 over 10 is going to equal, I'm going to look for DE. That's the first one they asked me for. Okay, DE is here. It's of the small triangle. And I need to find its matching side. There it is. 12 of the big triangle. So I'm going to put 12, the big triangle, over the matching side DE and solve this. This is what we call a proportion. We solve this by cross multiplication. 15 times DE gives me 15 DE equals 10 times 12. That is 120. So you divide by 15. So that makes that DE equals 8. So now we know that DE is 8. Okay, now we need to do the same thing, find AC. Okay. So I'm going to find AC. AC is the big triangle, and its matching piece was AE of 14 of the small triangle. So again, 15 over 10 worked for the first one, because that was big over small, is going to equal big, well, we don't know AC, so I'm going to put it in as AC, over its matching side of 14. 10 times AC is 10 AC, and 15 times 14 is 210. Now simply just divide by 10, and you'll get AC equals 21, which makes sense because it should be bigger than the smaller triangle, same as it did here. 8 is smaller than the 12. That makes sense. Okay. If you have any further questions, please see me after school.